A sequence in which the difference between successive terms is constant is called an arithmetic sequence. This is where you literally add a number to get to one for the next. That's not always true of sequences, but if you do add the same number from one to the next, then it is an arithmetic sequence. That number that you add is called the common difference, and we denote it with the letter D. So to find the next term in an arithmetic sequence, you literally add the common difference. Like, that's how easy this is. Determine the common difference and find the next four terms. So to find the common difference, you take the second term and subtract the first term. So if I were doing this particular one, I would say 12 minus 17. My common difference here is -5. So my common difference, that answer would be -5. And then the next four terms, I would simply subtract 5. So I would say 2, then -3, then -8, then -13. Arithmetic sequence. Yes? So do guided practice 1. All right, check your work. For the first one, you should have gotten a common difference of 31, and then your next four were -36, -5, 26, and 57. For the next one, a common difference of -57, 73, 16, -41, and -98. If you look at the pattern here, your first term is just whatever it is. In this case, they gave us a first term of 6. And they said the common difference is 3. So then my second term would be just the first term plus my common difference, or 6 plus 1, 3, right? My third term is going to take this term and add another 3 to it. So I have 6, and then I'm adding 3 twice, or 2 times 3. And then my fourth term is 6, and I've added 3 times. And so the pattern here is that the term you're on is always one more than how many times you've added your common difference. And so this is where we get this little guy here. If I'm on my nth term, then I would have 6 plus 1 less than the term that I'm on times 3. And that's where we get that formula for an arithmetic sequence. You can find, you can find your terms like this. So if I want a specific term, I can go straight to this. And I can say it's going to be my first term plus 1 less than whatever term I want times my common difference. So as long as I have my first term and my common difference, I can find any term in an arithmetic sequence. All right? And so that's where we get this from, just that pattern that's created. So look at example 2 on page 600. It says explicit and recursive formulas. All right, so let's talk about the difference. These are terms that we've used when we've talked about series and sequences before. Explicit is what we just talked about. Explicit means I can get to any term in the series without walking to it. So meaning I don't have to go 1, 2, 3, 4, 5, 6 to get to the 6th term. I can just plug a 6 into that formula and get my 6th term. All right. Recursive means I have to have the term in front of it. So you're going to write it considering that you have the term in front of it. And so if I look at this one here, my sequence is 12, 21, 30. So the first thing I need to do is find my common difference. So if I were to look at these 3 numbers, what number am I adding to get from one to the next? Yeah, so my common difference here is just 9. So if I were going to look at a recursive formula, then I would say to find my nth term, whatever term I'm looking for, I have to have the term in front of it. And we note that by a sub n minus 1, right? That's the term in front of it. I take the term in front of the one I'm looking for and I add my common difference. So that would be the recursive formula. The term in front of it plus my common difference. That's recursive, right? If I want explicit, meaning I don't want to use the term in front of it, I want to be able to find any term in the entire sequence at any time, that's going to look a little bit different. So for explicit, I'm going to say, well, a sub n is going to be my first term. And what's my first term of this particular formula sequence? 12, my first term, plus 1 less than the term I want, n minus 1. So if I want my 7th term, that's going to be 6. If I want my 25th term, that's going to be 24. 1 less than whatever term I'm looking for times my common difference. That's the pattern we just found. Now, when they want explicit, they typically want you to simplify it. So this is not simplified. Simplified would mean I have one variable and one constant. So to simplify this, I am going to distribute that 9 and combine my like terms. So I'm going to say 12 plus 9n minus 9. Combine your 12 and your negative 9. So your explicit formula would actually look like this. 9n plus 3. So that would be explicit. This one here would be recursive. And those would be your two answers. Recursive, explicit formula. So go ahead and try guided practice 2. So for this one, you should have gotten that your common difference was negative 12. And so if you did your recursive, then it's going to be the term in front of it. A sub n equals a sub n minus 1 minus 12, right? And then for explicit, you would have said it's your first term, which is the 35, plus n minus 1 times negative 12. And when you distribute that and simplify it, you would have gotten a sub n equals negative 12n plus 47. This information. Find the 68th term of arithmetic sequence, and they give us this. All right, so the 68th term, I mean, you could find the common difference and do that 65 more times, but that would be really the hard way, right? What you want to do is you want to find the explicit formula and then plug in the 65 for it. And so what I'm going to do is I'm going to find my common difference here. And what is my common difference? What's happening here? Specifically negative 8. So anytime you're going down with arithmetic, it's going to be a negative difference, right? And then I'm going to just plug that into my explicit. My explicit said I take my first term, 25, plus n minus 1 times my common difference, all right? And so I'm going to distribute that through. Negative 8n and plus 8. And so my explicit's going to look like this. Negative 8n plus 33. All right. And if you don't want to distribute, you don't necessarily have to. You can just plug a 68 in there, but whichever one's fine. All right. And so when I get that, I'm going to plug in for my 68th term, which is what they want. So a of 68 is going to equal negative 8 times 68 plus 33. And when I do that, I get negative 511. Now, if they did not ask you for the explicit formula first, you could have plugged it in right here. You could have just said 25 plus 68 minus 1, or 67 times negative 8. Same thing. If they do not ask for the explicit. If they ask for the explicit, it's a two-part question, which means you have to give that and that. But if they only ask for a specific term, then no, you can jump straight to the term. A little bit different. It says find the first term of the arithmetic sequence for which a sub 25 equals 139 and your common difference is 3/4. So in this case, they did not give you the first term. They gave you the other information. So you're just backfilling, right, and solving for what you don't have. So in this case, I'm going to say, well, a sub 25 should equal my first term, which is what I'm solving for, plus 25 minus 1 times my common difference, right? And they gave me this, so I just plug it in. The 25th term is 139. I don't know this, but I do know that I should have that, right? And you can calculate that. I mean, that's just, you can cancel here, right? 4 into 24 is 6. So we get 139 equals a sub 1 plus 18. Subtract 18 over, and you get that a sub 1 is 121. And so that would be my first term there. It says find the 38th term in the sequence. All right, and they've given you the beginning. 970 was your 38th term. And then find the common difference. So in this case, they were asking for the difference, not the first term. You should have gotten it -0.5 or -1/2, whichever way you wrote it is fine. For B, they told us the 38th term was 56.5, and the first term is 75. And so we're going to put that in standard, or the standard explicit that we have. The 38th term should equal the first term, plus n minus 1 here is going to be 37 times my common difference. And so I will subtract the 75 and then divide by 37. Because it's 38.
Oh, 38. Oh, gosh. Okay. Yeah, sorry.
Is that?
I messed up on.
Oh, okay.
I had it set up right. I just didn't put my in wasn't the right number.
I just didn't finish.
I did it 75 is mine. I did 75 minus 1.
Yeah. It's n minus 1, so that's your little subset point there. The first thing you know above it is defines arithmetic mean. If two non-consecutive terms of an arithmetic sequence are known, the terms between them can be calculated. These terms are called arithmetic means. It's basically an average between the terms because you know you're going up by a constant amount because it's an arithmetic. You basically use the concept that it is first term and then whatever term you are looking at. So in this case, they told us that there are 4 arithmetic means in between these two numbers. So my first term is going to be the 4.3. My last term is going to be the 12.8. And I have 1, 2, 3, 4 terms in between it, according to what they just told me. So if I'm looking at this as an arithmetic sequence, this is term number what? Well, this is 1, 2, 3, 4, 5, 6. So that's my 6th term, right? So they're telling me that the 6th term is 12.8 and the first term is 4.3. And so I can easily find those terms that go in between it by finding my common difference. All right, and so I just plug it in. Well, the 6th term should equal my first term plus n minus 1, or 5, times my common difference, which I don't know, right? And you subtract the 4.3 and divide by the 5, you'll get a common difference of 1.7. Well, now that I know that, I'm just going to add 1.7 each time, or I can plug into 3 and 4 if I want to fill those in. And so I'll get 6, and then 7.7, and then 9.4, and then 11.1. And those would be my 4 arithmetic means in between those two. You should have gotten -5.3 as your common difference when you calculated it, and then just when you add -5.3, those are your 6 numbers in between. Let's go over it. All right, so just scoot that up a little bit. All right, so for this one, 12.1 is my first term. Which term is -24.7? Your 8th term. That is your 8th term, right? You have your first term and your last term and 6 in between. That's 8 terms altogether, right? So a sub 8 should equal my first term plus 8 minus 1, or n minus 1, times my common difference. All right, so I'm going to plug in what I have. I have the 8th term. That's -24.7. I have my first term, 12.4. And then 8 minus 1, because that is 8, is going to be 7 times d. I'm going to subtract my 12.4. And then I'm going to get -37.1, hopefully. And I'm going to divide by 7, which is where I'm going to get my -5.3 as my common difference.
So if it's an...
All right, so basically the difference between a sequence and a series is you add them up. All right, you add them up. An arithmetic sequence is literally just the list of numbers. A series is where you add those numbers together and get a total. All right, and this is where we remember the story of Gauss, right? Y'all remember the story of Gauss? My favorite story, little Gauss. When he was in elementary school, teacher got upset with the class and said, I want you to add all the numbers from 1 to 100, thinking this would keep the little first or second graders busy for a while and no longer getting into trouble. Gauss, in a few minutes, had the answer because he recognized a pattern: 1 in 100, 2 in 99, 3 in 98. They all have the same answer. They're 101. Right? And he realized that if he go from 1 to 100, he's going to have 50 of those. So 50 times 101 is 5,050. And so within a few minutes, he had the right answer of 1 to 100. And so that's where we actually get this formula. You take how many terms you are going to want added together and divide that by 2. And then you add your first term and your last term, because that's how many sets you will have at your arithmetic sequence. All right, so that is your summation formula. Your summation is your number of terms divided by 2, your first term plus your last term. I want you to pay attention to this second formula and where they come up with it. If you don't remember the second formula, it's perfectly fine. You can naturally get to it. The way they came up with this second formula here is saying, well, n over 2, that's the number of terms divided by 2. My first term and my last term is going to be however many terms I'm doing, right? Times d plus my first term, right? That is my last term. It's my first term plus n minus 1 times d, right? And so all they did is they took the a sub 1, there's 2 of them, that's 2a sub 1, and then the n minus 1 times d. And so if you don't remember that one, you can just solve for your last term, right? Like you can just solve for it. And so you can just solve for your last term if you don't naturally have it. But that's where they came up with that second formula. So let's example up here. They want us to find the sum of these different series, okay? So the first one, they give us the first, they give us the last. What they don't tell us is how many terms we have, all right? So what we really need to know is what term I'm talking about. So what term is term 317? And so I can find that out, right? Whatever term it is, that's a sub n, right? Is going to equal my first term, -5, plus n minus 1, times, what is my common difference here? From -5 to 2, 2 to 7, what's my common difference? How do I get from -5 to 2 and 2 to 9? 7, all right? And so if I'm going to solve this, I can just distribute through. 317 equals -5 plus 7n minus 7. 317 equals 7n minus 12. We add 12 over and divide by 7. We're going to get n equals 47. So I know that this guy is the 47th term. All right? Does everybody see that? That's how I figured out what term I'm on. All right? And now that I have that, I can just plug it into my formula. The summation of these is going to be n. This, now we know n is 47. So 47 over 2 times my first term plus my last term. And when I add all of that up, I get 7,332. That's what the total is if I add all those terms in that sequence, all 47 terms. All right. When they say a partial sum here, 28th partial sum, they mean 28 terms. So they want 28 terms starting with 27. Now, again, you can do this one of two ways. You can say, well, the summation of 28 of those terms is going to be 28 over 2 times my first term, which is 27, right? Plus, well, what's my last term? My last term is going to be 27, my first term, plus n minus 1. What's my n? How many terms do I have here? 28. So 27, 28 minus 1, times what's my common difference? Yeah, how do I get from 27 to 14 and 14 to negative 13, right? So you can rewrite your last term in terms of what you did, right, to find it. And when you calculate all of that, you're going to get negative 4158. So if you don't know your last term, you can use that explicit formula knowledge to get it, right? This is just a sub 1 n minus 1 times d. That's what that is. So I just found my last term by calculating it. And that's where they used that 2 times a sub 1 plus your n minus 1 times d. That's where they got that from. All right. Let's look at the last way you'll see this. You will also see it in summation notation. Summation notation, that's the Greek letter sigma, and it means to add it up, right? To add up everything that's in that. And so I have to then calculate my first term. Now, how many terms I have? How many terms do I have here if I'm going from 6 to 28? One more. So yes, you do say 28 minus 6, which is 22, but you do have to add the fact that you're counting the 6 as well. So it's going to be 23 terms here. So I'm going to say n over 2, so that's 23 over 2. My first term, well, how do I get it? I plug a 6 into here. To get my first term, I'm going to say 5 times 6 minus 17. To get my 28th term, I'm going to say 5 times 28 minus 17, right? So you're going to calculate those. 13 is your first term. 123 is your last term. And when you add all of that up or calculate it, 1,564. They have a tournament in which the gamers compete in multiple games and accumulate an overall score, pays the top 20 finishers. First place receives 5,000, second 4,800, third 4,600, and so on. How much total prize money is awarded? So I have 20 total, right? That's my n. So I'm going to say n over 2. My first prize, what's my first prize? A sub 1. 5,000, right? It's going to be 5,000. What's my last prize?
46.
My last prize, we don't know, right? So we're actually going to use that formula where we double our a sub 1, right? A sub 1 plus my n minus 1 times d, all right? N minus 1, what's my n again? 20. So plus my n minus 1, so 20 minus 1, or 19. And what's my common difference? How is it changing from first to second to third? What's my common difference? Negative 200, specifically, right? It's going down. All right? So that's where you use that 2 a sub 1 n minus 1 times d. So if you do all of that, you're going to get 62,000 in prizes. So you will get 10,000. Fortunately. Is that better? Carter has been collecting baseball cards since his father gave him a 20-card collection. During each month, Carter's father has given 5 more cards than the previous month. In how many months will he reach 1,000 cards? 1,000 is my summation. We don't know my n, right? So in this case, we're going to say 2 times my first. He started out with a 20-card collection. Plus, we don't know n minus 1, but we do know d. How many cards does he get per month? 5. And so you're going to back into your n. You're going to solve for it. This will give you a quadratic, which means you're going to have to use the quadratic formula to solve for it, right? So when you do all of this guy, you're going to get 2,000 equals n times 5n plus 35. So when you distribute and move that 2,000 over, you actually get a quadratic. 5n squared plus 35n minus 2,000. quadratic formula, negative b plus or minus the square root of b squared minus 4ac with 2a, right? You will get a positive and a negative answer, okay? You can't have a negative number of months, so use your logic. Obviously, you're not going to use your negative answer there. And so you do have to use the quadratic formula, which hopefully you remember.